Dr. Thompson here, looking at topic 12 for the third exam in 145. This is on optimization. It's going to be a little harder to show you what's going on because I think that when you set up the equation, you should just go ahead and graph it in Desmos. This app won't let me transition to Desmos while this is up, so you'll have to trust me on part of this. So the first number here, it says find the pair of numbers whose sum is 5 and whose product is a maximum. So the product of two numbers, I'll call the numbers x and y, and we'll call the product p. That would just be x times y. But the whole point of this section is to graph p against one variable and just graph it and look for the max or min. And here I have x and y, so I need to figure out how to get rid of one, but their sum is 5. So let's get rid of y, because y is 5 minus x. And then let's put it into this equation. So p is x times 5 minus x. And at this point, it's okay just to go ahead and graph that in Desmos, which is what I'm doing now. And you will see a maximum on this graph. You'll see a vertex, and x here is 2.5. And since y and x sum to 5, y is the same number. Alright, so and then the product is 6.25, which Desmos will show you that for the other point. But usually when I'm looking at Desmos, I'm really interested in the x value of the graph I look at, but you should be careful what you're asking for. Here I'm asking for the pair of numbers, so I didn't really care about the answer to the product. In the next problem, I actually don't want the dimensions, I want the largest area. So on this next problem here, let's go ahead and do that one. In this next problem, I really want to know about the largest area, so I don't care what the dimensions are. However, fencing is only needed on two sides of this region. Okay, so I've got some sort of place here, and I'm putting fencing on where the blue is, and maybe it's like that, maybe it's longer, but I only have 500 feet of fencing. But the area is going to be xy, if we call those sides x and y. And I know that those add up to 500. So this is actually a very similar problem to the first one. You can change y to 500 minus x, and then you can graph this just like we graphed the first one. Of course, you're going to have to change your window or zoom out quite a bit in Desmos because these are much larger numbers. But it looks like you get x to be 250, and again, it ends up being a square as the optimal area. Alright, so that is number 2. So now let's look at number 3. An open rectangular box with a square base is to be made from 48 square feet of material. What dimensions will result in the box with the largest possible volume? So you got a square base and an open rectangular box. So the volume is going to be x squared y if x is the base and y is the height. But it's 48 square feet of material, so that's the sum of all the faces. Remember, there's nothing on top. So each of the 4 faces on the side, right? Here's x, here's y. There's 4 of those, right? And then there's also the bottom, which is x by x. So this is going to be 4xy. This x, by the way, I meant 4 times. There's 4 of those, but then there's also the material on the bottom, which is x squared. Now, this is going to be kind of messy, but when you look at this one, I'm just going to solve this for y, because solving for x looks awful. And then I will substitute it here. So 48 minus x squared equals 4xy. And now let's divide by 4x. And now let's make that substitution. So my volume finally ends up being this mess. 48 minus x squared over 4x. Okay. And I'm going to go ahead and graph this, although I will point out you can cancel an x, right? In fact, we can make this, if you wanted to do this with a derivative, you can make it much nicer. This is now 1/4. Let's put the 4 over front here. 48x minus x cubed. So you could take the derivative and look at the quadratic made by the derivative. But I'm going to go ahead and graph this. And I want to know the dimension, so I would like to know x. And this is going to be kind of a bear to look at, so I'm going to have to change my window in Desmos. Let's make x go. X can only be, what, from 0 to 48 maybe? And my y-axis can't be that big. Let's make y go from 0 to... There we go. So it looks like I'm looking at the point on Desmos of 432. And that means x is 4. And I need to plug that back into this, because the second point is the volume, right? This is x comma volume, so x is 4. But I need to look here to figure out y. So 48 minus 16 is 32. Divide by 16 to get 2. So y then would be 2. So those are my two dimensions. 4 by 4 on the bottom and then 2. So I guess the answer was not a cube in this case. I will mention one other thing, just a point of irony, a point I made that I then screwed up. On the second one, I wanted the largest area. I figured out that the 250 and 250 were the dimensions, but I should have actually multiplied those, right, to get the maximum area. I did not. I just took for granted that the dimensions were what I wanted. And so when you do that, it's 250 and 250, but the area on the second one should have been 62,500. That was the actual answer to the problem. Alright, so that is topic 12 from the exam 3 review.